Hello and welcome to SQL to Python. This is a crash course illustrating SQL equivalents in Python. So who is this course for? Well, if you're a data or business intelligence analyst, an analytics professional, a researcher, or aspiring data scientist, then this course is probably for you. There are a couple of prerequisites though. When starting this course, you should have a base knowledge of Python, which basically means you have Python installed with the Pandas library. If you're able to get there, then you're in good shape. If you have an IDE to follow along, whether it's VS Code or PyCharm, that would be extremely useful so that for your learning. I recommend VS Code if you don't have PyCharm. It's a great free alternative. Optionally, if you have the ability to connect to a MySQL database, you'll be able to run like the SQL yourself in case you want to experiment and try different scenarios. Now, I recommend you download the code files. Again, that is optional. You can clone or download the repository at the link shown right here. And the course files will be in the subfolder titled SQL to Pandas. Now, if you're going to connect to MySQL, here are the credentials. Feel free to pause the video, make note of it, and create your connection. And lastly, I recommend a couple of other free resources so that you can stay up to date with my content. You can check out my YouTube channel, and I ask that you subscribe if you like my content. And also, you can check out my other free resources on Udemy with the following link. Thank you, and looking forward to you taking this course. Hello and welcome. Today we're going to compare SQL select limit function with pandas and see what the counterpart is. So if I go to my database, I'll have this table called age income. In this table, I have 100 records, and I want to just limit it to the first 10 records. So if I want to do that, I simply type limit. If I want to be able to do the same thing in pandas, assuming I have the same data set in a CSV file or some other format, or even if I connect to my database and I want to do the same thing, I import pandas. You can kind of ignore this. This is just so I can grab my data file, read it into my pandas data frame, and to show you how to do that, just apply the head function. By default, head will give you the first 5 rows on its own, but you can also specify how many rows you want to preview. Run that, and here we go. The first 10 rows in the data frame. All right, thank you for watching. Now is be able to select distinct value across multiple columns, or even just one column. If I go back to my data set and I take a look at my values, let's just say, for example, I want a unique or distinct look at the values for marital status. I can do that simply by going to my database and typing select distinct marital status and running that. Here I see I have 5 values, including a blank. If I want to do the same thing in Python, after reading in my data, I can type df, my column name, and now drop duplicates. And I'm just going to go ahead and print that so we can look at that output in the terminal. And here we go. We get a series, or really just a trimmed down data frame of the marital statuses. Of course, you can do that with multiple values. So, excuse me, if I wanted to also include income, for example, there's probably not going to be many duplicates there, but let's just say I want to do that as well. I would do the following. Thanks for watching. Hey, this video we're going to look at querying a subset of columns. So if you take a look at our table, age income, here we have 4 columns. Let's say we're just interested in returning back name and marital status. We can simply type name, comma marital status, execute our query, and we have these 2 values back, right? So if we want to do that in pandas, we simply just do the following. Calling your file name, in this case Again, we're using ageincome.csv. And in a list format, you actually want to type name and marital status, the name of the fields, right? And let's just say we want to see the first 5 rows. So we'll go ahead and print that out. And we'll run that. And now we have name and marital status. So using this list, right within brackets after the df, after the date frame name, will get you the 2 columns that you want. Cool. Thanks for watching. In this video, we're going to essentially mimic a where clause with pandas. So if I go to my age income table in SQL, and let's say, for example, I want to see all the records where the marital status is married. I would simply say select all from age income where marital status equals married, hit enter, and I get all the married records. Now, if I want to do the same thing in pandas, I'm going to bring in my data file in, the one we've been working off of. And what I'm going to do is actually I'm going to create another filter here within these brackets. I'm going to say df marital status double equals to married. And so like now I'm saying this is the filter that I'm going to apply to my data frame. And let's go ahead and take a look at maybe the first few records. As you can see, I have some squiggly lines here, so there's an error here, and that's just, well, actually, I think I had an extra bracket. There we go. Okay, that should be fine. And let's just go ahead and print so that we can view the results down here. And here we go. We get records that have a marital status equal to married. So that is one way to filter within Python. And we'll cover a couple more in a little bit. Thank you for watching. In this next video, we're going to try to address querying pandas with multiple conditions. So if I go to my data, if I go to my database in my table age income, and I want to get the records where marital status equals married and ages, let's say over 30, for example, or 35. Let's just go with 30. I would type the same select statement as before, add another predicate line, and say, and age is greater than 30. So I run that, and I get these records where everyone's age is greater than 30, and of course they're married. So, all right, good to go. If I want to do the same thing in Python, again, I'm going to read in my file name, and this time I'm going to say df, same as before, marital status equals married. Okay, and now I'm going to put an ampersand for and another set of parentheses. I'll say df age is greater than or equal to 30. And that should give me my set. And I'll just go ahead and print this so that we can see the results. Run it. Oops, I misspelled that. There we are. Great. Now we get a result set with everyone who is married and under the over the age of 30. Easy peasy. Thank you very much for watching. See you in the next video. Earlier, we touched on a couple of examples where we can use multiple conditions, such as the where clause and the like. Let's take a look at a different scenario though. So if I'm just going to run this, for example, let's, in terms of this record set, I can see that I have same marital status, various ages, and various incomes, and so on. Let's say, for example, I was looking for just a subset of people, right? And let's pick the first 3, Gisela, Heather, and Hiroko. and I want to go ahead and basically filter for them. Well, if I chain it like before, it's definitely going to be a lot of chaining. So maybe there's an easier way to do this. And that's where we're going to use the SQL in statement. So in this case, instead of writing these two conditions, I can basically say where name in, type Gisela, Heather, and Hiroko. Now this is a rather small data set, so it's likely that I'm just going to get them three back. In larger data sets, of course, you'll get more, and you'll have to apply more conditions so that you get the exact records that you're looking for. But in this case, yeah, I only got these two back. I think I might have misspelled the other name. Oh, I misspelled Heather. There we go. So I get these three records, right? So in this example, with these values, I get those records. So basically, I'm just going to take these values really quickly because I'm going to use them later on, and then demonstrate how to do this in Pandas. So we're going to declare a list with those three values, with those three names. And now we're going to say df, and again, we're going to have this filter here. And instead of using name, which I definitely can, I'm going to introduce something new, and I'm going to say dot name, and then dot actually is, excuse me, sorry about that, is in, and I'm going to introduce this dot is in and this parentheses, and I'm going to put names here. And so basically, this is going to filter or look at or evaluate, like filter pretty much the data set where these three values in this list are found in name. And let's go ahead and print that. And we'll run it. And here we go. We get Gisela, Heather, and Hiroko right here. And that's all we do. So a little bit easier, I think a little bit cleaner as well. Thank you for watching. In the last video, we basically did an equivalent of this SQL statement where we searched for records where name was in one of these three values. What if we wanted to do the opposite though? What if we wanted to get some values that that are not represented in a list, right? So basically a not in. So I'm going to focus on something a little different other than these three names. Let's say, for example, I wanted all records where marital status is not, or excuse me, not in. Let's just say married, divorced, and what's another popular one? Single. So essentially, we should get everything that's either blank or null or other, right? So I'm just going to copy these values because I know I'll use them in a little bit. And I'll start with a new file. Go ahead and bring in the information or the data into your data frame. Then we are going to create a list variable with the values that we had earlier. And this is going to be very similar to that other example that we had, where I'm going to say df marital status dot is in, and I'm going to say status. Now if I run this, of course, let me just print that. If I run this, I'm going to get everything that is single, divorced, or married here, right? But that's not what we're looking for. So we're going to use this unary operator, I think it's called unary, which is basically a tilde, and it negates this true statement. And so basically you're saying where it's not any of these things. And I'm sorry, that's not where it goes. It actually goes right here in this first set of brackets where the condition exists. So let's go ahead and run that. And now we get all other statuses, right? Any status that isn't married, divorced, or single. So which is basically left us with the blanks and other. is what we are returned. Cool. Thanks for watching. Hello and welcome. The next couple lessons I'm going to talk about how to retrieve or compute just basic statistics in pandas and similar and its counterpart in SQL, or basically vice versa. So if I look at my initial data set, I can see that I have a couple of numeric columns that would be age and income. If I wanted to get the average income of the group that we have, or of the people in this data set, I can simply run this statement, select average income from age income, and it'll give me this value. Now, let's say, for example, I want to do the same thing in Python. So, let's see, I'll call this file compute average. Basically, I'll just read in my age income table from the CSV file. And this one's actually going to be pretty easy. So since we're needing the average income value, all we have to do is get the series or the column income and type mean. In this case, mean is average. And we'll go ahead and run that. Actually, let me run that again. I ran the wrong file. And you see that we get 97, 360, 31, the same as when we ran it on SQL. And here we go. Easy as that. Thank you for watching. See you in the next one. Hello and welcome back. In our last example, we figured out how to compute the average income, both in SQL and then translating into Python using pandas. In this example, let's go ahead and determine how to calculate the max income, or the max of any value for that matter. So if you notice here, in SQL, I simply just change average to max, and that does the trick. Python is going to be absolutely similar. So if I want to get the max, and in this case, let's just say age. Maybe we're interested in what the max age is for our group. And let's run that. Excuse me, actually I ran the wrong one here. Now we see that this person in our group, or potential people, it could be more than one person, but the max age in our group is actually 77. So one or more people can actually be of the age of 77, but we know for sure that the highest value in terms of age for the group is 77. Thanks for watching. It's very similar to what we did before, and in reality, we don't need to create another file. We can just work off of the one that we created. And this is just to touch on getting the min of things. So if I run that, in order to get like the min value, we can see that the top income is 150 and the lowest income is 46K. So in this data set, let's say we want to get the min and max age. I'm just going to add a comma here, type df age, and you guessed it, just simply type min, parentheses, run that. And there we go, 77 and 24 are the lowest age value in our group is 24. Thanks for watching. In this video, we're going to talk about computing the mode. So in SQL, actually in most databases, it's actually very difficult to compute the mode. You typically need to set up a couple of temporary tables, bring it all together in order to find out the mode. But let's talk about what the mode is. The mode is the most common occurring value in a series, right? Or in a table. So if I look at my data or my table age income, I see that I have a list set of ages here. So if I want to know the most commonly or most frequent recurring age, it's very difficult to say mode. Like there isn't a function for mode in age. That just really won't do anything. So what I would probably have to do visually, if I want to make it simplistically enough, I would say age, count, and then group by 1, or group by age really. And so if I run that, I get the counts of ages. Now I want to see which is the most frequent, so I can say order by 2, descending, and that'll give me 27 as the most frequent age. So visually I can see that, and that's what essentially the mode does. So in Python, I'm going to once more bring in my dataset or read in my file, which is this ageincome.csv, and it's the same thing as the table. And so now if I want to get the mode of something, I would simply say data frame age dot mode, and I'll just go ahead and print that out. And if we run it, then here I see I get 27. So 27 is my mode for age in this set of data. In this video, we're going to talk about the group by aggregate function. In this specific case, we're going to be grouping by category and summing. If we look at our data, we see that we have 4 columns: name, marital status, age, and income. We know that these 2 columns, age and income, we can execute an aggregate function on. So what we'll do is we will get the marital status and sum up the total income by marital status. Granted, that doesn't make a lot of sense, but there are use cases where you will actually apply this. So let's take a look at how that is done in SQL, and I think everyone is pretty much familiar with it. So we'll just say marital status sum and then income, and we'll alias it as total income. Then we will group by marital status, and we'll leave the order by 2 descending. So here, when we run our query, we see that the group of people that are single with single marital status actually cumulatively have the most amount of income. That could be because on average they make more, or there's an outlier, or maybe there are more people in that category. Whatever it is, this is what it totals to. So I want to do the same in Python. I'm going to go ahead and read in my file, the age income file that we've been looking at. And now what I'll do is I'll type df.groupBy, and here is where I'll put in the field or the column that I want to group by. Then I'll use the ag function, and I'll type sum, the field name, income, and the function that I want to apply, which is sum. And let's go ahead and print that. Need to run the right file. There we go. And as you can see here, again, we have single with the highest most value, divorced, married, other. Cool. This next example, I want to talk about another aggregate function, and that is mean. Again, this is a basic descriptive statistic, but we're going to look at it and apply it in a slightly different way in Python. So let's go again to our marital status example, where we're looking at average income, and maybe we want to get average age as well. So let's go ahead and do that in SQL first. Now this is a more meaningful statistic in some way with this data anyway, because we may be interested in knowing what the average income is by average age. So in some respects, and marital status, so that may be a little more meaningful. So we'll keep our query as is, as we just typed it up. And here we see we have blank, divorce, marital status, other, and single. And average income per category, this is what it looks like, right? Again, the singles being with the highest income overall, and their average age being 50. So everyone's around close to 50. So now if we want to implement the same thing, or look at the same thing in Pandas or Python, we're going to do the following. We're going to say df group by marital status, and in this case, because we're going to get both columns and we just want to see the mean for all of them, we're just going to type mean. And this is a lot simpler, a lot easier to do, so you can do this both ways. And we want to print our results. And we have divorced, married, other, and single. Now, one thing that I did overlook in the last column, however, though, was that our blank value or null value is overlooked, and we don't have that information displayed here. So in order to capture that, we're basically say drop NA is equal to false. So it means like any category that is null, just basically show it. So let's run that again. And here we go. The blank category now shows up and is consistent with our console, with our, our SQL rather. Cool. Thank you. Cover the count function. We've seen this before, but let's just go and cover it a little bit in a little bit more detail. So let's say, for example, I'll keep marital status again since that seems to be a pretty good category, and I want to count just the number of records by marital status, right? So I'll alias that as record count, run that, and here I get the number of people in each category. Now if I want to do that in Python, again I'm going to read in my file, pd read CSV, and the function is very similar to the other ones that you've seen, where we're selecting marital status as our group by field, and I'm going to go back to using ag, and the reason is we'll see more examples and more variation when we actually use ag. So I'm going to just, I guess I can count really any field since I'm really counting one, and I'll choose income for example, or I can choose name if I want to change it up a little bit, and count, and of course I'll print this and run it, and here we go. Again, we are missing the null values, so if we want to ensure that we bring those in, we'll basically set drop NA to false, run it one more time, and here we go. This video we're going to talk about getting multiple aggregate values. Let's take a look at how that would look in SQL. So again, I'm going to go back to my marital status and basically get a couple of aggregates based on or grouped on this value. I'll get average age, and I'll alias that as average age, and I will get total income, and I'll alias that as total income. So once I run that, I can see that I basically get average age per group and also total income. So if I want to do that in Python or through Python Pandas, I'm going to read in my information, and basically I'm going to group by marital status one more time. And again, I'm going to use my ag function. And this is why I like using ag function, because you can actually bring in multiple aggregate types. So the first one is going to be on age, and that is going to be the average or mean. And my next one is going to be on income, and for that I'm going to get the total. And if I go ahead and print that and run it, I'll see that I get age or average age right here and total income. Again, if we want to be able to see like the null values, we will say that drop NA is equal to false, run that one more time, and we get the nons as well. In this next example, I want to talk about computing row number. Now, the version of MySQL that I'm working off of does not support row number, so I cannot write the SQL for you here and demo it, but I can say that in a case like this, you can basically select all columns. What you would want to do is rather select all columns, type row number, and you would have it over partition by, and here you'd have your column name like income or what have you, and you would have your order by, and let's say age for example. So well, probably make more sense is marital status. So what would happen here if MySQL supported this statement, you would get basically a row number for every change in marital status. So at, let's say, married, you get 1, 2, 3, 4, 5 until you hit single, then it's reset, and you would order your data set by age. Now this won't run because again, it's not supported, but essentially your data set would look something like this, where you'd have all the marital statuses grouped and then a row number as depicted here, 1, 2, 3, 4, 5, resetting at the next marital status. So let's see how that looks like using Python. So after reading in my data file, I'm going to type df.sortValues, and this is where I'm going to choose how I sort my data set and how the row number should be applied, like in what order. So here I'm going to actually select name and age, so it can sort by name and age. Then I'm going to group by the column or the value that I want to reset at every change, right? So in this case, it's going to be marital status. Then I'm going to add a cumulative count. I'm going to add 1 to a cumulative count. And so I'm not going to necessarily preview this because it's not going to make too much sense. So instead, I'm going to assign this to a column, and I'm just going to call this RN, for example, for row number. Once I do that, then we'll go ahead and print RN. Excuse me, we'll print our data frame. We'll print like the first, actually let's just print it all. We won't see all on our screen, but you'll get the picture right now. So once we run that, now we have the same data set as we saw earlier, where you have basically a name and then a row number applied. If you notice, this isn't sorted, so if I go ahead and sort values, and I'm going to sort by name, actually name and marital status, or actually marital status, it's name and marital status, because my initial sort was actually by name and age, but I think this will kind of paint the picture. If not, we can always change it up. Alright, so if you see here, and maybe that's not the best one to do it. So let's just do name, marital status, name, and then age, and I think that will give us like the clear picture. Okay. Here we are. So now, if you notice here, we have the name, the marital status being divorced, and then it's sorted by like name and age actually. But here's the depiction of the row number, and that's what we really want to see. So yeah, that's how you do, or that's how you execute the row number function that is found in SQL, but in Python Pandas. This video I want to cover the case statement. So as you all know, you can write a case statement based on or derived off of your existing data. So if I look at my data set, again, I have name, marital status, age, and income. I'm going to create a very simple one, basically based on age. Anyone under 30 is going to be like considered a newbie. Someone between 30 or 31 and 50 will be like intermediate level, and anyone 50 or above would be an expert at whatever they do, right? So let's start by typing our case statement. Case when age is less than or equal to 30, we'll call them newbie. When age is less than or equal to 50, then we'll call them intermediate. And when age is less than, or well, actually, we'll just say when age is greater than 50, then expert. And I think that should probably cover everything, but we'll just add another case statement here. So if it doesn't fall in any of those ranges or it's something else, then we'll just be like no label. There you go. And we'll say end as experience level. That should be good to go. So if we run that today, everyone's given an experience level based on their age. So we see this 26-year-old being a newbie, and this 59-year-old being an expert. So we're good to go. So if I want to do that in Python, it's going to require kind of two pieces, and you may not necessarily find this as useful because you'll be thinking like, well, I'm writing more code with Python, but just note that it's more flexible. So we'll start by defining a function first of all, and we will call this expert level. And basically we're going to take an age as our parameter. So we'll say if age is less than or equal to 30, then return newbie. If age is less than or equal to 50, return intermediate. And if age is greater than 50, return expert, else return no label. And now that we have our function, it's essentially like our case statement, right? Except that it's in a function. So I want to apply this to my data frame, and so I'm going to type in df dot experience level is equal to df, and since we're evaluating age, we're going to use the age column. So we'll say df age dot apply lambda x, and then we will call in our function, which is expert level, and then again pass x. So for every value in age, we're going to apply lambda, and the result of it is going to be our data frame. So once we're done that, we'll just go ahead and just put in a few records on our data frame and see how that turned out. So let's run that. Here we go. Now we have name, marital status, age, and so on. And really what we're looking for is this categorization of experience level based on age. So this individual is 74, so they're an expert, considered an expert, and then this guy is 38, so intermediate, 27, newbie, and so on. So you can see that you can really add a lot of complexity in your function. So this is kind of nicer than a case statement because you can also put it in a different class and then just call it in. So at first it may seem like a few more lines of code than you expected, but it is a bit more powerful. Example, I'm going to cover joins. So if I look at my age income table, I see that I have 4 primary values: name, marital status, age. I also have another table called name children, which provides the name of the individual and the number of children that they have. So in order to join on this, I'm going to type inner join name children on a.name equals nc.name, and if I run that, I'll see that I have name, again, both tables, and children. So really all I need at the end of the day is just all the columns from table A and the number of children from table name children, and that'll give me the number of children that each individual has. So in order to do this in Python, I'm going to read in my data. Now I do have another flat file that basically parallels that other table named children. So I'm going to bring that in a different variable. And I'll simply just rename this to age income, and this one to name children. And just change the name of that file. And so for my first data frame, I'm going to read in the age income file, and my second data frame, I'm going to read in the name children file. And I'll just name these df1 and df2 respectively. So now that I have that information, maybe I just kind of want to preview what that looks like. We already know what our first data frame looks like. Oh, it's df1. And no surprise there. And our second data frame is basically the name of children. So in order to join this, I'm going to type pd.merge, and I'm going to call the first data frame kind of my left table in my when I write joins, or if I'm thinking about joins. Then my second data frame. Then I'm going to say how I'm going to join this, and we can have inner, we can have left joins, we can have right joins, and we can have outer joins. For this instance, I'm just going to use inner. And since I share the name column in both tables, I can just basically put on is equal to name. If like name was name in one table and first name another, I would simply type left on, and then the column value there, and then right on, and then the second column over there. But since they're named the same, I can eliminate all that and just say on equals name. Once I have that, I want to go ahead and just, I think I can just preview from here. So let's go ahead and print that here. And here we go, we get the first 5 records of this joint data set, all with children. Now if you wanted the results saved to a data frame, of course you can always do that. And maybe I'll say call this data frame number 3. And now I can print the results of data frame number 3 and get the same information. Oh, there we go. And there we have it. So now that's our combined data set, and we can work on it however we want to. Thanks for watching.